Hello, so in today's video, we're going to look at composite functions. So you may have seen composite functions before, perhaps maybe at school, GCSE level maths, but we're going to just go into more detail, just revise what composite functions are. So I've got a little example here. So we've got two functions, f of x equals x plus 1, with a domain x in the real numbers. So x can be any real number, so I specified a domain here where x can be any real number. And I've got a second function here, so g of x equals 4 minus x squared, and I've specified a domain. The domain that I'm choosing is every real number. So x can be any number that you like in the real, on the number line, on the real number line. Okay, so what does it mean to compose two functions, or what does it mean to take the composition of two functions? So the composition is just basically a way of combining functions. Essentially, you can think of it. You can think of it like that. Basically, you can think about combining functions. So the way we say it, we say f composite g, or in other words, f of g, evaluated at a real number x. X could x again is just a real number or real variable, really, I should say. So f composite g or f of g can be written in the following three ways. So there's three ways in which you may see this written as. So in the A-level syllabus in the UK, you'll probably see it written like this. So f, g, and then with the x that you're inputting into that function. You may also see it with the brackets actually like that as well. You could see that too. Yeah, so A-level syllabus is normally use this kind of notation, the f next to the g, and then the x input in the brackets there. I put this like kind of annoyed face here because I don't really like this notation, because you could get confused and you could think, oh, that means f times g, but that's not correct. No, this is f of g, or f composite g. So yeah, this is I don't like this notation, but we're going to use this notation just because this is a notation that you'll probably see in your high school A-level syllabuses. This is the notation they tend to use, but I don't really like this one. I prefer this second one here, this f of g of x, because it makes it very clear and very explicit that actually what a composition of functions is you're actually substituting this second function, this g function, into your f function. So you're inputting this g of x function into your f function. So I prefer this notation here. This notation to me makes more sense. It's more logical to me. You also may see this notation as well. So you tend to see this at university if you study maths or a mathematical subject at university. University professors tend to use this quite a lot. I quite like this notation, I guess. It's this f and then a little like dot o with a little hole in it. G, this function evaluated at the number x. I mean, it's quite a good notation in the sense that you can it kind of explicitly makes clear that you're composing two functions, because in theory what you're doing is you are composing two functions and then you're evaluating a number, you're evaluating that function at a number. So I guess it makes theoretical sense, this notation, but I mean you won't really see this in A-level maths, high school maths. You won't really see this notation here. This is more university pure maths where you see this notation. So we're going to stick with this notation in my videos, because yeah, that's the A-level syllabus notation really that's used. So yeah, let's go to the next page. So our first question is to find f of g of x. So again, I'm just going to make this clear what this actually means. So f composite g, f of g, this is just the same as saying f of g of x. We want to find this function. So we're going to calculate the function. So this is again the same as f evaluated at g of x. Now g of x is 4 minus x squared. So let's just plug that in. So plug in 4 minus x squared into that, just by substituting that for that. And then what we're going to do is we're going to plug in 4 minus x squared into our f function. So every time we see an x, we're going to swap it with this 4 minus x squared, because we're going to substitute in this number into the function. And so if we do that, we get this x substituted for 4 minus x squared. So that's 4 minus x squared, and then the plus 1 there, plus 1. So we get 5 minus x squared. And so therefore, that means that f g of x, this f composite g function, evaluated at the value x, is going to be 5 minus x squared. Okay, so that's our first example. Now let's look at the second one. So g of f of x, so g composite f. So this function again is the same as g, but evaluated at f of x. Now we know that f of x was this, if we go back, it was this x plus 1 function. So we're going to substitute in x plus 1 into g. And then now we're going to look at our g function and we're going to say, okay, so every time we see an x, we're going to swap it with this x plus 1, because instead of substituting an x into our formula, we're substituting in x plus 1 into this formula instead. So that's what we're going to do. We're going to plug in x plus 1. So we're going to get, sorry, I'll do this in black ink again. So 4 minus, and then instead of an x, substitute x plus 1. So substitute in x plus 1 all squared. Now, what's this going to give us? So this is going to give us 4, take away x plus 1 times x plus 1. If we expand those brackets that we get, just move this up a little bit. Expanding those brackets, we will get, so 4 take away x squared plus 2x plus 1. And if we just simplify all this, 4 take away 1 is just 3, so we get 3 there. And then minus 2x minus x squared, because we're minusing the 2x and we're minusing the x squared. So that would be our function. This would be our g composite f function, or in other words, our g of f of x function. So that would be that there. So yeah, I mean, that's just really a brief summary of what composite functions are. We're just composing functions. We're just evaluating a function at a different function. Basically, we're plugging a function into another function and we're getting a new function as a result. So that's kind of the key takeaway from this video. You can also think about evaluating these functions at actual numbers. So for example, g of f of 4, again, it's the same kind of process. You're evaluating g at the value f of 4. Now, if we go back to our f function, we know that f of 4, let's just make a note of this here. So f of 4 is when you substitute in the number 4. So 4 plus 1, that gives us 5. So actually what we're doing is we're just plugging in the number 5 into g instead. So f of 4 you just found on the previous page there to be 5. Did the calculation, plug in 5. So plugging in 5 into g, and we know that g is 4 minus x squared. So we're going to write 4, and then instead of an x, write a 5 there, because we're plugging in 5, square that. So 4 minus 25, so that's equal to minus 21. And if you actually plugged x equals 4 into this result down here, you should also get the same thing. 3 take away 2 times 4, which is going to be 3 take away 8, which is minus 5, and then take away 4 squared to take away 16. So minus 5 minus 16 is minus 21. So yeah, we can also use this as well to substitute into our substitute the 4 into this result down here, and we get the same value. So that's just a summary of composite functions so far. But how about the domain of a composite function? So the thing is that we've actually got two functions now with two domains. I mean, in this case, they both got the same domain. So I mean, you can probably guess that the domain of this f of g function, this f composite g function, and the g composite f function as well, will be the same, and it will be. It's going to be x in the real numbers. But what happens if you've got different domains? If you define different domains, if you've actually got or specified different domains for your functions, what would our domain for this composition of functions be? We're going to do that in the next video, so I'll save that as a treat for the for tomorrow's video. So we'll look at the domains of composite functions in the next video.